Hello students, myself Karunakar Bhuga, working as an assistant teacher for mathematics subject in Bethel English Medium High School, Gangavati. So today we are going to discuss the unit that is coordinate geometry. What is this coordinate geometry? Already from the lower class we are very familiar with the word geometry. So in that we are going to learn what is the length, what is triangle, what are quadrilaterals, how to find the perimeter of a triangle, area of a triangle, etc. And coordinate means Cartesian system. If I would like to say in one word, graph. So in that Cartesian system we are going to learn the concept of the geometry. So that is called as coordinate geometry. Learning the concept of geometry in Cartesian system. That is called coordinate geometry. Coming to the important things in this components in this unit is, first is distance formula, section formula, midpoint formula and area of the triangle. So first let us take the distance formula. So if I take a Cartesian system, I will take 2 points P, which is of coordinate x1, y1, and one more point I will take Q, coordinate point as x2, y2. Now I want to find the distance between these 2 points, that is PQ. So to find the distance between these 2 points, we are going to have a formula that is called as distance formula. How it is represented? So PQ is the distance that will be given by the formula square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula used to find the distance between the 2 coordinate points. Let us take one example. P is of coordinate points 8, 3 and Q is a point of the coordinate points 0, 9. Now we will find the distance between P and Q. So PQ is equal to, so x2 minus x1 whole square plus y2 minus y1 whole square. So P, denote it as x1, y1, this as x2, y2. Now substitute all the values in this. Square root x2, x2 is here, that is 0 minus x1 is 8, so 0 minus 8 whole square plus y2 it is 9 minus y1 that is minus 3, keep the bracket, one more bracket here. So whenever we are having the minus values, we should be very careful. Now simplified, square root 0 minus 8 is directly here, you can take minus 8 whole square plus simplified inside the bracket, minus into minus plus 3 whole square. So take up the values, 8 square minus 8 whole square is 64 plus 9 plus 3 that is 11 square. So square root of 64 plus, sorry, it is 12 square, that is 144. Now add this one, we are going to get 208. So this is how we get the distance between the 2 points using the distance formula. The next is, if in the same, if I want to find the distance of a point P from the origin, this is the point where x-axis and y-axis they intersect, that is called as origin. its coordinate points are 0, 0. If I want to find a distance of a point P which is of coordinate x, y from the origin, means from the origin how far is this point P? So this distance can be calculated by a separate formula, that is called d is equal to square root of x square plus y square. Square root of x square plus y square. So let us take an example. Let us take the same point P, 8, minus 3. So P of 8, minus 3. So D is equal to, this is x and this is y. Formula square root of x square plus y square. Substitute the values. 8 square plus minus 3 whole square. So 64 plus 8 square is 64. 3 square is 9. 64 plus 9, that is 73. So in the examination we may get 1 marks question for this distance of a point from the origin. If it is in case of distance formula where we use the 2 coordinate points, that can be asked for the 2 marks. So this distance formula helps. What are the uses of this distance formula? Distance formula helps us to verify the given triangles as equilateral triangle, or to find the perimeter of a triangle. So to decide whether the given triangle is equilateral, means all the 3 sides of a triangle must be equal. Even they may ask the isosceles triangle, verify the isosceles triangle, or sometimes they may ask to find the perimeter of a triangle. So in that view, the distance formula helps us to verify those things. Now next let us see about the section formula. This formula, suppose there are 2 points. One is P, x1, y1, having the coordinate point x1, y1. One more point Q, x2, y2. So here is a line, straight line. This line is divided in some ratio. So say for example here. So M1 is to M2. Say for example, this line is divided in the ratio M1 is to M2. There the point will occur. So what will be the coordinate of this point? What will be the coordinate of that point? Let us take it as A. Already we have taken P here. Let us take it as A. So what is the coordinate of this point? To find that coordinate point, section formula will help us. So the formula of the point A of x, y is given as look at the easy method of remembering the section formula. First, denominator you write m1 plus m2, and here also m1 plus m2. In the numerator also you write m1, leave some place, write m2. Here also m1, leave some place, write m2. Now here is the thing, we have to substitute some one more values here. See here. Denominator m1 plus m2, numerator also m1 plus m2. Here also denominator m1 plus m2, numerator m1 plus m2. So this part is nothing but the x coordinate. X coordinate we are having 2 values, x1 and x2. So as here it is m1, here you have to take x2, opposite. Then here if it is m2, you should take x1. Then here this is the y coordinate. So we are having two values, y1 and y2. So m1 is there. So y2, m2 into y1. This is how we can remember the section formula. So m1 into x2 plus m2 into x1 divided by m1 plus m2, comma m1 into y2 plus m2 into y1 by m1 plus m2. So this is the section formula. In that section formula, one more formula we are going to rise. That is called midpoint formula. So that is what is the same ratio, the line P of x1 comma y1, Q of x2 comma y2. Midpoint, the word itself says midpoint, means the ratio m1 is to m2 will be equal to 1 is to 1. m1 is to m2 is equal to 1 is to 1. Midpoint means exactly middle point of this line, means the ratio will be always 1 is to 1. So by that, substituting the values of m1 and m2 value as 1 and 1, so we will get a formula. That is, let us take this as b of x comma y, midpoint. So the coordinate of b of x comma y will be equal to, that is just m1 is 1, means only x2 remains here. So here m2 is 1, so x1 remains. So here m1, m2, 1 plus 1, that is 2. Similarly, y2 plus y1 divided by 2. This is the midpoint formula. So both are like a co-brothers. Section formula where ratios are different, and the midpoint formula when the ratio is equal to 1 is to 1. Now let us see one example for each section formula and midpoint formula. So here we have an example. There are 2 points A and B. A is of coordinate 4, minus 3 and B is of coordinate point 8, 5. These 2 points are divided in the ratio 3 is to 1. Now we have to find where the point lies. So that is the point we have taken as P. Formula is here. Now we will substitute all the values. So take it as x1, y1. This one as x2 and y2. So m1 is 3, m2 is 1. You can keep the arrow mark like this. So now substitute all the values in this. So let's move that. m1, that is 3 into x2. It is here 8 plus m2, that is 1 into x1, that is 4, divided by m1 plus m2, that is 3 plus 1. Move to the y coordinate. m1, that is 3 into y2, it is here 5 plus m2, that is 1, y1 is minus 3. Be careful when we have the minus signs. So divided by 3 plus 1. Simplify, general mathematics. 3 8 ja 24, 1 4 ja 4, 3 plus 1, that is 4. Then 3 5 ja 15, plus into minus, minus, 3 1 ja 3. So 3 plus 1, 4. Continuing the simplification. So 24 plus 4, 28 by 4, comma 15 minus 3, that is 12, divided by 4. So you can cancel it. 4 1 ja 4 7 ja. So and 4 1 ja 4 3 ja. So the point 7 comma 3 is the point which divides the line joining the AB in the ratio 3 is to 1. Let us see one example for the midpoint formula. Say we will take the same example A and B. So what is the coordinate of a point which lies exactly in the middle of the line? So we apply the midpoint formula. Midpoint formula is, so let us take the point P as the midpoint of the line joining the AB. So x2 plus x1 divided by 2, y2 plus y1 divided by 2. So take this, substitute the values. x2 that is 8 plus x1 that is 4 by 2. y2 that is 5 plus y1 that is minus 3, keep it in the bracket, all divided by 2. So just simplify. 8 plus 4, 12 by 2, 5 minus 3, that is plus into minus, 5 minus 3 is, so we can take directly 2 divided by 2. So cancel that. So the coordinate of the point P will be 2 1 ja, 2 6 ja, so 2 1 ja, 2 1 ja, so 6, 1 is the point which divides the line joining the AB exactly in the middle. So section formula and midpoint formula, they are also having their own advantages. So in section formulas, you should remember we get the problems over trisections. So that kind of problems also you should practice well. And midpoint formulas will help us a lot. For example, there is a parallelogram. In that I draw a diagonal. So one more diagonal. So as we know that in a parallelogram, diagonals bisects each other. Bisects each other means they divide equally. Means if I take ABCD is a parallelogram, AC is the diagonal, and if I need the coordinate of this point, midpoint, means we can make use of this midpoint formula. Okay. Next, let us see the last component of the unit, that is area of the triangle. Now let us see the last component of this unit, that is area of a triangle. So what is that? Say in the Cartesian system there are 3 points P, Q, R, and they are joined to each other. So I want to find the area of this triangle. Basically we know the area of the triangle is half into base into height. But here in the coordinate Cartesian system, we are going to learn how to find the area of the triangle. So the formula is ready for that. Area of triangle is equal to. Here also we can have some technique to remember the formula. That is how is x y minus y plus x y minus y plus x y minus y. First write like this: x into y minus y plus x into y minus, all are same, x into y minus y plus x into y minus y. Now we will allot the numbers, because we should understand x1 y1, x2 y2, x3 y3, there are 6 points. So x1 into y2 minus y3, see the serial, 1 after 2, 2 after 3. Then here x2, next number is 3, then 1, cyclic. So 1, 2, 3, cyclic. Okay, then finally x2 is over, x1 is over, remaining is x3, after that y1 minus y2. Like this writing you can practice the formula, because formulas are very important. If we make a single mistake, the total problem will go wrong. Now let us see one example for this, finding the area of the triangle. So the points are like this: A of -2, 1, B of 4, 6, and C 6, 3. So there are 3 points: A of -2, 1, B of 4, 6, C 6, 3. So now we will find the area of the triangle joined between these 3 points A, B and C. So formula: area of triangle so that is half into x1 into y2 minus y3 plus x2 into cyclic y3 minus y1 plus x3 into y1 minus y2. So now give the names. This is x1 y1, x2 y2, this is x3 y3. So substitute the values. Half into x1, that is -2, bracket y2 minus y3. y2 is 6, y3 is 3. 6 minus 3 plus x2, that is 4, y3 minus y1. y3 is 3 minus y1 is 1 plus 6 into y1, that is 1 minus 6. In the bracket, go for simplification. -2, keep it as it is. 6 minus 3 is 3 plus 4 into 3 minus 1 is 2 plus 6 into 1 minus 6 is -5. Then proceeding with that, -2 into 3 -6, 4 2 ja 8, 6 5 ja plus into minus 30. So half into -6 -30 -36 plus 8. So if I proceed with that, half into -36 plus 8. So plus into minus, so that is 28 with minus sign. 36 minus 8. So if we cancel, we get minus 14. What is this? We got the minus value here. Area of the triangle as minus. No need to worry, because in this Cartesian system, sometimes while finding the area of a triangle, we are going to get the negative. But what you have to do is, finally while writing the value, you should write it as plus 14 square units. So whenever we get negative, don't feel it is a wrong one, somewhere we have done the mistake. No, sometimes we get the negative. So I have taken this example. So turn it into positive and write the answer. Hello students, myself Suvarnasiri. So here we are going to discuss the unit that is called as construction. So which is going to have 5 marks in the annual examination. Okay, so totally this unit is a skill oriented unit, means all we are going to have the constructions here. The main 2 components of this constructions are, first one, that is construction of a similar triangle. Okay, so a triangle will be given, so we have to construct one more triangle which is similar to the before triangle. Then one more is construction of a tangent to a circle from an external point. Okay, so first we shall look after the similar triangles, construction of similar triangles. construction of similar triangles. So to construct a similar triangle, the data what will be given? That is, first one, measurements of a triangle. So to construct a triangle, what are the measurements required? Maybe 3 sides or maybe 2 sides and 1 angle. Okay, so such kind of data will be given. And one more point what will be given is ratio of corresponding sides. So what are similar triangles? That already you have studied in the unit triangles. So here that similar triangle concept we are going to construct practically. So here we are going to have a practical idea of the similar triangles. So let us take one example here. So construct a triangle ABC where AB is equal to 4 centimeter, BC is equal to 5 centimeter and AC is equal to 6 centimeter. And construct another triangle whose sides are 2 by 3 of the corresponding sides of the first triangle. So the ratio of the corresponding side is 2 by 3 here. 2 by 3. So here I am going to write the point here about the ratios, because the method will be differing as concerned to the ratio, that is numerator and denominator. Okay, so there will be having 2 methods. Okay, so as concerned to the given ratio, there will be 2 methods. Both the methods we will see in this example. So I have here, first we should draw a triangle, that is the measurement having AB equal to 4 centimeter, BC equal to 5 centimeter and AC is equal to 6 centimeter. From the lower classes you have learnt how to construct a triangle. Now let us see it once again. So here we have one example. Okay, so AB equal to 4 centimeter, BC equal to 5 centimeter, AC equal to 6 centimeter and the given ratio is 2 by 3. As I said, there are 2 methods. What that 2 methods is, that depends upon the given fraction, if it is a proper or improper. See here denominator is greater than the numerator and here numerator is greater than the denominator. If in such cases the method of construction will be slightly different, that we will see here. First we have here, I have taken AC, that is 6 centimeter. Then take a compass and take the measurement of 5 centimeter. Draw one rough diagram here. So AC is here, this is 6, this is AB, that is 4 centimeter and this is 5 centimeter. So take a measurement of 4 centimeter and cut an arc and take a measurement of 5 centimeter, that is BC, that is 5 centimeter. Now join them. So here what I have constructed, they are not exactly of 4, 5 and 6 centimeter. On averagely we have taken the measurement. While you are doing the problem, take the exact measurements from with the help of the scale and construct the triangle. So ABC is here, AC is 6 centimeter, BC is 5 centimeter and AB is 4 centimeter. After finishing the construction of a triangle, the next similar triangle, how we are to construct? In that, the first step is draw a line. Draw a line which makes an acute angle. Just acute angle on average. There is no any prescribed angle. On average, draw one line, and that line you have to divide equally. So you take one standard measurement. While you are using on your papers, take 1 centimeter or 2 centimeter as one unit. So here I am taking some prescribed unit. So the measurement what you are taking in your compass, it should be standard. Fix it once. Is it 1 centimeter or either 1.5 or 2 centimeter, and you should draw the arcs. How many arcs you have to draw? So you have to draw the highest number of arcs what you are having in the fraction. Here the highest is 3. So I have drawn 3 arcs. Then with the help of the scale, you have to join the last point to the point C. So here it is. After joining the last point, okay, so what is the denominator? So that you should locate first. Okay, denominator is 3. 1, 2, 3. From this point, you have to draw to the end. Then, with the help of the protractor, or sometimes even you can take the help of the set square also. Here I have the protractor. I take the help of the protractor and measure this angle. So keep the protractor like this. So I am getting here 70 degree. Okay, so then you have to keep it on the point 2. So that is the numerator. Then the 70 degree lies here. So while you are doing in your paper, so measure the angle accurately, then take it easily. So here it is. No need to go up to here, just where that line cuts the side base of the triangle, just you draw it up to there. That means, remember, this angle and this angle must be equal. Then measure this angle. Okay, we should measure the angle C. So here in my construction, angle C is standing on the 34. So keep it on this point and take the same angle, that is 34. That comes here. So thereafter join the line from here. So as much as possible draw the dotted lines by which we can identify the triangle which we have constructed. Now we shall give the name. So here is A, B and this is C. Let us give some name for this. Take it as C dash. This is C dash, and let us take this as B dash. Now is a triangle formed. New triangle is formed here. That is A, C dash and B dash. So which is similar to the triangle A, C, B. This is how we have to construct the similar triangle. Similarly, here in the case it was denominator bigger than the numerator. Now we will see when denominator is lesser than the numerator. So here the same triangle, taking the same measurements, the triangle is ready here. Then next, the step what we have followed here, same steps we have to follow. You have to draw one line which makes an acute angle. Then take a compass having some equal standard length. So 1, 2, then 3. So after taking the arcs, now look at the denominator. Always in these problems, look at the denominator. Okay, here also it was 3. So first we have located the third arc, and here it is the denominator 2. First we locate the arc number 2. Okay, so from there you have to join to the point C. Then you should measure that angle. Keep the protractor neatly. Then measure the angle. Here for me it is getting nearly 112. Okay. Now what you have to do? The triangle which is similar to this is getting externally outside. So what we have to do is we need to extend the lines here. So first you should extend the line AC. Keep it in a dotted line. Then even you extend this line also. That is AB. So after that, the measurement of this angle, which I got it as 112. Okay, in my measurement it has got 112. So it will not be same as when you are doing in your paper. So measure the angle accurately. Then move to the numerator. Number 1, number 2, number 3 is here. Keep it here and take the angle, that is 112. It goes here. So then with the help of the scale, join them. And even we have to measure this angle as how we have measured here. Same angle should be constructed at this point. So the angle was, that is around 30-32. So I am taking that. So then join that line from that point. So here is the triangle. So give the name. So let us give this as C dash and let us give this as B dash. The original triangle, sorry, the given triangle was A, B, C. Now the obtained similar, the triangle which is similar to this is A, C dash and B dash. So finally we write the result here. A, C dash, B dash is similar to triangle ABC. So that is what you can see, the two methods in the construction of the similar triangles. Next we shall see the how to construct a tangent to a circle from an external point, which is going to take up 2 marks. These constructions are going to carry 3 marks. So totally the unit is going to cover 5 marks. So already you are having a knowledge of a circle and a tangent. A tangent is a line which touch the circle at one and only point. So that line is called as a tangent. Now for that circle we are going to learn how to construct a tangent from external point. How it looks? If the circle is like this, somewhere the external point is here. So from there we are going to we are going to construct a tangent from that external point. This is external point. So there are three cases. There are three cases in this. First case, the data what will be given is, he will give the radius. Means when we are drawing a tangent to a circle, means the very important thing of construct the circle is radius that is needed. So radius will be given. Then he will give the distance of that external point, maybe from the circle or from the center, which I am going to take it as a D. Okay. So two data will be given. One data is radius of the circle, another data is distance of the external point from the center or from the circle. If we give from the center, we should take the measurement from here. If he asks from the circle, the measurement should be taken from here. So that is how we are going to do. We will learn here with an example. So let us take radius of a circle as 6 centimeter and the external point is 10 centimeter away from the center. So that will be considered as a D. So there is a circle of radius 6 centimeter and a point is 10 centimeter away from the center, and he is asking to construct a pair of tangents, okay, to that circle. So first thing is we should draw a circle, okay, of 6 centimeter. So here is a circle of radius 6 centimeter. Then you should take 10 centimeter from the center. You should draw an external point. So I am going to take here. So my dear children, remember here I am taking the measurements not accurately, averagely I am taking, because just I am explaining you the method how you have to construct. So here is the circle which is of 6 centimeter radius, and here is the point that is 10 centimeter away from the center. So let us take that point as P. So from here to here it is 6 centimeter, and from here to here it is 10 centimeter. After getting this, after constructing a circle and locating the external point, we should take more than half. More than half you have to take. Draw the arcs on the either side. Keep it on the point P. So after getting the arcs intersecting, so join them. So what we did here, just with the help of these intersecting arcs and the line joining, we got the midpoint of this. Okay, the distance from the center to the external point, we got the midpoint of that. Then from that midpoint, we should take the distance from the point to the P. Then we should draw a circle. So just a point P is coming outside, so I locate here itself. So So that will exactly fall on the point P. As this is the midpoint, then the new circle what we have drawn, so that intersects the before circle at 2 points. So from those 2 points you have to draw a line to that external point. That is the tangent to the circle. So let us give some name for that. So you join from that point to the center. So let us give some name for that. P already we have given. Let us give this as Q and this as R. This is O is the center. So which are that? PQ and PR are the required tangents. Sometimes he will give some extra for that. That is, measure the tangent and verify. Okay. So for that we have a formula, that is length of tangent is equal to square root of d square minus r square. How this formula is obtained? This formula is obtained with the help of the Pythagoras theorem. That is, the radius drawn from the circle to the point of contact and the tangent and the distance of the external point from the center, it forms a right angle triangle. As this is the hypotenuse, from that a formula is derived here. Length of the tangent is equal to square root of d square minus r square. So substitute the values. D is 10 square minus radius is 6 square. So 100 minus 36, that is 64. That is equal to 8 centimeter. The tangent what you have drawn here, so that should be exactly, that is PQ should be equal to PR is equal to 8 centimeter. This is how you have to construct a tangent to a circle from an external point. That is the first case. Second kind of problems will be there. That is second case. Radius of the circle will be given. Radius of the circle will be given and angle between the radii. Angle between the two radii will be given. So with that we have to draw the tangents to the circle. That is how we will see now. So here we have an example. So draw a circle of radius 5 centimeter and the angle between the two radii is 60 degree. Construct a pair of tangent to that circle. This is one example. So first you have to draw a circle of radius 5 centimeter. So one radius I have drawn here. Then you should observe here angle between radii, means you should draw two radii. Between the two radii the angle must be 60 degree. So one radii I have already drawn. So one more radii we shall take, whose angle between them will be, the angle between the two radii will be 60 degree. So the tangents will be getting down here. So we shall draw that radius little above here. So first radii I will draw here. Then take the 60 degree. Here is a 60 degree. Draw the line. So now the angle between the radii, two radii is 60 degree. Now we have to draw a pair of tangents to this circle. So how we have to draw? Take a compass. So keep it here. First we shall draw a tangent with the help of this radius. So keep it here. Take more than half. Take more than half. Draw the semicircle. Draw semicircle. Then keep it here. The first arc will be falling here. Then from there draw one more arc. Then third arc. Then keep it here. Then draw the fourth arc. So I repeat. First you should take here more than half. Draw the arc. And from here, without disturbing the measurement, draw first arc. And from there continuing the second arc. And from there the third arc. Keep it here and draw the one more arc. So we got the point where these two arcs are going to intersect. From that intersecting point, I am going to draw the tangent to this circle. This is the point of contact. So this is how we have to draw the tangent. Similarly, the same procedure you have to follow for this another radius. So keep it here, take more than half, draw the semicircle. Number 1, number 2, 3, then number 4. 4 arcs you have to draw and then join them. Here is a point of contact. So join them, extend them so that these two are, let us give the name P, Q, right? So this one let us take R. PQ is a tangent with the help of this radius and QR is another tangent. You can look at here, both the tangent are intersected here. So what about this angle? That angle is called as angle between the tangent. Angle between the tangent. How much it will be? So very clear. Think that this is S or take it as O. R O P Q. If it is a quadrilateral, so sum of opposite angle, that is angle between the radii plus angle between the tangent will be always equal to 180 degree. Angle between the radii plus angle between the tangent is always equal to 180 degree. So now it was the angle between the radii is 60 degree, means the angle between the tangent will be 120 degree. The third case of the problem, if I look at here, that is radius of the circle will be given, angle between the two tangents. Angle between the two tangents. A question you have in your textbook. I read here. Draw a pair of tangents to a circle of radius 5 cm which are inclined each other at an angle 60 degree. Which are inclined. Which are means tangents are inclined at 60 degree, means angle between the tangent he has given as 60 degree. So remember, if this is a circle, so this is the angle between the radii, this is the angle between the tangents. So here he has given the angle between the tangent as 60 degree. So if he gives in such a way, so very simple, with the help of this property, angle between radii plus angle between tangent is equal to 180 degree. If the angle between the tangent is 60 degree, so the angle between the radii will be 120 degree. Thereafter you have to follow the same procedure, drawing a circle, one radius and another radius whose angle between them will be 120 degree. Then you have to follow the same procedure by which you can get the angle between the tangents as 60 degree. So these are the three cases of the problem. So first case is only the radius and the tangent, the distance of the tangent by external point will be given, and second one is radius, angle between the two radii is given, which we are seeing the construction procedure here. And the third one is radius of the circle is given, angle between the two tangents will be given. At that time we have to take the help of this property. When the angle between the tangent is given, with this property first you have to find the angle between the radii, and you have to follow the same procedure how we have done for this. So my dear children, construction which is taking over 5 marks, one 2 marks question and one 3 marks question, it is totally skill oriented component. So practice all the problems very easily, so prepare them well, and all the best for your exams. Thank you.